Alright, let's continue. Oh, and also I found the repository for, what is it called? For the homework. Alright, so previously I'm kind of confused. Let me open this. Okay, let's start. I'm kind of confused, right? Where is the homework source code? This one, process test run. And then I'm like, see the readme for the tile, which readme should I say? So it turns out it is in this GitHub repo. Let me copy this in the chat, but I also have this on the description if you want to take a look. Okay, so maybe we can check this on the homework, something like this. Maybe we can check the source code on the terminal emulator. Okay, see readme. Process run. I think this one. Then where is the readme? CPU intro readme. Okay. This program called process-test-run.py allows you to see how the state of a process of a process state changes as it runs on the CPU. Okay, as described in the chapter, process can be in a few different states. Okay, I did check this one. I think it was, where is it called? Where is it? Something like this, right? Running, ready, and block. I think this one, the simplified view of the three state: running, ready, and block. And where, how to switch the process depends on the policy. Where is it? Let me, this one. Policies are algorithms for making some kind of decision within the operating system. Which program the operating system run? Which program should the operating system run? Okay. So the switch in the example here, right? Running, and then the first process initialize input-output, so it become block, right? Let me check in here. In block state, a process has performed some kind of operation that makes it not ready to run until some other event takes place. So some other event take place in this case is the input-output process, or maybe request is the word. Input-output request which haven't finished yet until this one, right? And then this is the state of the first process change from broke to ready. It is this one. Process is ready to run, but for some reason the operating system has just not to run it at this given moment. So I'm assuming that in this scenario, the policy is to finish one process first. So there is no priority for the process one or the first process here. That's why it is become ready rather than running again. I mean, if in the policy the first process was prioritized, I think this state might be running rather than ready, and then the second process, this one, become ready instead. So kind of pause if the first process have a priority. We will pause the process, the second process, so it become ready instead. Another scenario, you could say. But in this case, we finish the second process first, and then we are resuming the operation from the first process. Again, it depends on the policy, right? Which process to prioritize, something like that. Okay, this is the state, right? Running. The process is using the CPU right now. Okay, the process could be using the CPU right now, but some other process is, okay, right? Block the process is waiting on input-output, for example, and then done. The process is finished executing. Okay. So we add another state, I guess. It is done, right? But yeah, basically it is almost the same as in the book, except for this state, the finished state, or in this case done. Okay, in this homework, we will see how this process state changes as a program runs, and thus learning a little bit better how these things work to run the program and get its option to this. Okay. I'm kind of curious about the code. Okay. Is this some kind of, what is it? Indicator, maybe? Okay. Or just some initiator. Let me check. Okay. Process with behavior. Keep set of instruction for each of the process. Okay. This is the, what is it called? Initial value, maybe something like that. Okay. New process. Okay. Where do we get this proc ID? Oh, this one. Okay. Alright, state ready. Program looks like this. Compute for 7. Not program. Okay, Let me mark this. Print function. Okay. I think we don't need to install the dependency. Maybe let me check. I mean, we added having TC ping, so maybe we can do something like this. Process, okay. Must be number. Okay. Well, yeah. We need to give some kind of argument, or maybe option is the right word. Okay. I mean, I usually would also print out the usage like this, even without the, what is it called, the flag. But again, it is very subjective. I think something like it. See, Git without any argument also prints the usage by default. But we can also use this, or right. See this flag. It depends on the preference. Okay. Load program. Okay. C7I C1 and I, which means compute for 7. Then then input output. I think the I is input output and the C in this one is compute, and while 7 is the, I'm not sure what 7 is. Is it the number of process, or maybe something else? But I is input output operation. Okay, compute for 1 and then input output again. I mean, this is the compute one, right? Save proc info. Maybe 7 or 1 in this case, right, is actually the process spawn. assuming from this one, because we append, right? This is the process. Oh, the process ID. Okay. Code. Okay. To compute CPU. Maybe compute in this one is spawning the number of process. Okay, I will find that out later on, I guess. Add one compute to handle the input-output completion. Hello. Welcome, Neil T. Mino. Did you finish the Build Your Own Lips journey? Yes. I mean, I didn't finish the book. Let me check. I didn't finish the book because I want to focus on learning C, right? And I feel like until chapter 11 is good enough for me to learn C. And well, I'm not sure about the next chapter. For example, the chapter 12. I've tried that the lambda function implementation cannot handle, what is it called? The function without parameter. So I stop at the chapter 11 and focus more on the C implementation, like trying to implement copy string functionality to replace strcpy, and then truncate value scenario with snprintf, and then also use union. This is the new one. Where is it? I think in this, wait. Oh, right, I also add the handwritten notes in case you want to check that out. This one. So basically, instead of having num, sim, and error with their own memory location, I'm trying to use union. I mean, I didn't do this on the live stream, but yeah, this is what I changed. So I'm kind of moving on from the Build Your Own Lips journey because I want to learn the operating system, but sometimes I add some improvement if I found some inspiration, like using this union data type, thing like this, because as far as I understand, we only need one value at a time, either num, error message, or the symbol. So it should be fine using union in here. So yeah, for the live stream, I'm done with the Build Your Own Lips, but sometimes I add some improvement off stream. Oh, and also this one, in case you want to check my notes. It might not be correct because I'm still learning to. Okay, let me copy this in the chat. topics you want to explore. Also, of course, there is this playground, right? When we exploring about the sympathy concept or something like this, the standard function using memmove. What happened if we use the 0 as the size? And looks like we'll not copy any bytes from the source to destination. Again, you can check this out yourself, exploring this. Okay, anyway, I've moved on to another learning materials, which is learning the operating system. Okay, where am I again? I think this one. This is the input-output operation. Okay. One compute to handle and the input-output confusion. Oh. Okay. Maybe compute is actually adding the process. I mean, here is the comment, right? Add one compute to handle input-output completion. So, okay, where is it? So maybe I and C1 kind of the same. It is adding one process. The difference may be that the I is adding a specific input-output process, while in the C, the compute, what is it called? Operation. I am not sure what kind of process we are adding in here. Bed opcode. What is opcode? Opcode? Is it on Python specifically? Oh. Okay. Wait a minute. Oh. Let me copy this in the chat. Very interesting. I might try to book sometime. It looks fun. Yeah, I mean, for learning C, it is kind of fun, but at the same time, as the chapter go on, it become complex very quickly. So you need to be patient by trying out the Lisp book, and also to prevent the tutorial hell, right? You need to analyze what can be done differently, Don't, what is it called? Do not just read the code from the book or copy paste the code from the book to your source code. Try to think, is this necessary? Or maybe we can do something else, like what I did with the union data type, right? Or maybe another stuff. If you have some inspiration, good content, man. Well, thank you. Okay, I don't think this is. Oh. we need opcode module potentially set between this and other module. Let's operate. Okay. Let's operate on bytecodes. Okay, so what is opcode in the Python? Hacking the interpreter. Is simply the numerical code for that operation. What operation is this? List of instruction object. Each instruction represents a single step. The Python virtual machine takes when executing your code. Okay, let me check in here. I think this is the opcode. Oh, so the opcode is operation code, which means that we have this opcode, right? This is what it will do. And opcode to the compiler, not used by the interpreter. It used in assembly code result in. Oh, system error unknown opcode. Okay, this is the assembly. What is it? Trust the assembly code from this opcode. Maybe that's it. Okay. Think of it like a unique ID number for the action the instruction perform. Has one numerical value. Okay, so in this one, the opcode means the operation code. So like some kind of instruction ID, maybe something like that. Oh, yeah. Let me copy this in the chat. In case anyone wants to read this too. The raw opcode. Check here's instruction. Okay. Well, let's focus on this first. Guess. Should be C or I. Alright. Exit. Okay. And then load. Then program description split. Okay. Path description must be number, where X is the number of instruction and Y is the percentage that an instruction is CPU, not input output. I mean, do we need to use triple print function here? I mean, can we just like put this in one function? Maybe. Like what? Using the triple single quote, something like that. Well, Python doesn't really distinguish between single quote and double quote, right? Okay. Num instruction in CPU, okay. Cadence. Open. Num instruction. Okay, this one. The number of instruction is the random number less than CPU. Wait, can we do this? I don't think we have the LSP set up yet. Or else at on computer and the confession. Okay, so this is the start of the input output, which I assume is block, right? The block state, maybe right? This one. Sorry, this one, the block state. Maybe this is the block state, and this is the ready state, maybe. Like, again, the input output done, right? In the book, where is it? Something like this, maybe. The input output done, right? So the process become block when we are in the input output in this one to IO, right? And maybe this is kind of the ready state after the input output operation. Maybe I'm still assuming, I guess. This is still just a hypothesis, which might be incorrect. Okay, move to ready. Alright, move to ready. State ready, okay. Okay, and then move to wait. State wait. Hold on a minute. Oh, state wait is blocked. Okay. So this one is the block state. This is the ready state. This is the block state, and this is the running state, and this is the done state. This one, the process is finished executing, and then the next process, I assume. Okay. And then get num process, get the number of process, okay. Get the number of instruction, alright. Get instruction, okay, get number active. I am assuming this is the number of process that is currently active. Right, the state is not done. So does that mean running ready and block? Maybe. I mean, what is it called? The condition is as long as the state is not done. So maybe this tree, what is considered as the active process. Okay, right. And then get the number runnable. Oh, okay. The number runnable is the ready state. Okay. Or running. The ready state or running. The ready state or running. Let me do this instead. See, this one or this one, the state running. So runnable is two conditions, the ready and the running state. What is iOS in here? Input output, the plural, what is it called? The plural of input output. Proc info. Okay. Input output in flight. Maybe something like that. So the input output that currently exists, maybe that's it. Num in flag. What is the flag in here means? So yeah, I'm assuming this is the total of, what is it called? The input output that currently going on. I'm assuming. This might be wrong. And then the space, okay. What space in here? Is it adding like the literal space character? Interesting. With 10 space, is that it? Maybe. Like if done. Okay. If the current process is 0, check if I think the last process is still running, right? If the last process state is still running, we change the state to done. I'm assuming in here expected. Okay. And then the next process. Oh, sorry, this might be the exit code, not really the total process. If the exit code is 0, right? We check if the state is still running or already done. If it is still running, then we change the state to done, and then we move to the next process. Okay, and then this is the run. The run mechanism, I guess. How many lines? 342 lines. Okay. Take outstanding input output. Oh. Yeah. The iOS previously in this one might be input outputs like this one. The plural of input outputs. Okay, track outstanding input outputs per process. Finish time. Okay. Current process 0 moving to running. Oh. Make first one active. Okay. So is the first one not active by default? Maybe output header for each column. Okay. PID. I kind of forgot what this means. Is it like, I think, what is it called? The total of character. I mean, there is also the dot, right? Something like, oh, not dot, maybe dot, right? I kind of forgot. Something like this. Let's find out. Format specifier. With number element, I guess. I mean, as far as I understand. The default Python virtual machine is in C. To C Python. Okay, in case anyone curious, C Python. This one, as far as I understand, this is the, what is it called? The virtual machine that we use on the default Python. We put this in the chat. I overslept again. Sorry. It's okay, ping pong. That's fine. I mean, you can still watch the VOD if you are curious. Okay. Right, where is it? Not in here. Ah, this one. Right. Think the left assignment. Okay. A number after specifies the minimum field width to be print if the characters are less than the size of the width space. If it is greater than it is printed as it is without truncation. With precision. Let me check. Python. What is it called? Let's try this. Something like this. Wait. I kind of forgot. Oh. Wait a minute. Space, right. Wait, not that one. Let me try copying this. What? Oh, okay. How many characters it is? Let me check in film. 10, okay. B, C, D, E, F, G, H. Okay. So it kind of moved the, what is it called? Or maybe the maximum one. Or right alignment is, maybe that's the word. The right alignment. Not that one. Okay. Okay, maybe that's it. The PID, right? CPU input output. Headers for each column. Okay. Init statistic. Clock tick. Plus equal 1. Input output done false. Check for input output finish. Okay. Clock tick in finish times input output true. Move to ready. Okay. From the wait state. Okay. And then immediately. Oh, input output run immediate. Alright. Oh, this is the policy, I assume. Input output done behavior. So it kind of, what is it called? Checking which one we should run first. Again, let me check definition of policy here. Algorithm for making some kind of decision within the operating system. Which program should the operating system run, right? And then near the end at this one, the status whether it is ready or running depending on the policy. Which program should we run? And maybe this is how to determine those policy, like input output done behavior. What should we do when the input output is done, right? Especially after we, what is it called? After we move from the block state. Again, this state underscore web is actually the block state, which can be confusing. If the behavior is to run immediate, then we immediately execute those running process. So first thing first, if the current process is not the process after, what is it called? It's not the process that have this policy, I guess. It's not the current, it's not the process after the input output done. This one, right? The current process is not the PID that have the input output operation. Then we move the current operation from running to ready. So in this case, right, if we are using this policy, this IO run immediate rather than ready for the first process, we will actually having this as running, the state of the first process as running, and the second process will become ready, as far as I understand from this source code. So we move the current process that is running, this one, that have the running state, and then move that to the ready state, right? That's what this function do. Basically, moving the process to the ready state. We are moving the current process to the ready state. It is after this one in the, what is it called? In the example, after this one, this will become ready instead of running, and this one will become running instead of ready. If we are using this policy, the IO run immediate with the, what is it called? In the IO done behavior. So if the IO done, what should we do, right? Something like that. Oh my god, why did you always stay in the morning? Did you working at night or like having other activity? Well, I like learning in the morning because it is peaceful, you know. Nobody bothers me during the morning. It's just personal preference, I guess. But yeah, if I have some activity in the morning, then I will doing the live stream later on. That's why there is no really fixed time for my live stream. I just doing live stream whenever possible. That's basically it. Okay, and then we set the input output, not really the input output, the process that have input output, right, as the next process, something like that. See this one, move to running from the ready state. Then, well, this is the mechanism. Okay. Oh, +1. Okay, did we? What is it called? Oh, if we have more than one. Proc info, proc state. If the state is ready, move to running. Okay. What is this check? Is this like checking the next process? Like, this is the current process, right? +1. If the state is ready, then moving that to running. What? Okay. If PIT is not -1. Oh, we change the current process. Okay. Alright, so we are executing this one because we provide the PID, the process identification. Okay. But if we didn't process if we didn't provide the PID, we will execute this one, or maybe this one. And I'm kind of curious why. Oh, because the first, the range condition. Okay. Start from the first and at the, what is it? And at the current process +1. So the one process after the current process. Maybe that's the word. Okay, anyway. Next process. Okay. We set the current PID as the next process. And well, because we provide the PID, we put the state as the running, right? The running state instead of the ready state. Okay. Put output run later, right? So after the input output done, we will run it later on rather than running that immediately. So the, what is it called? The illustration is something like this. This is in the, what is it called? In the ready state rather than the running state. Okay. Self process switch behavior, get switch on N and get number runnable. This means the process that issue the input output should be run. Input output should be run. Okay. So is this another policy, right? Process switch behavior. Get switch on N. Switch on N and get number runnable more than 1. Okay, so should be run. Switch on N equal 1, so run it. Switch on N, I'm assuming the switch on N in here means that if it is at the end of the process list, but again this, what this condition mean? Get num runnable more than 1. Get num runnable more than 1. So we get the number. Oh, if it is in the ready state or the running state, right? If there is any process in the running or ready state, well, more than 1, right? Maybe if there is the two, what is it called? The two process, one with running and one with ready. That issue the input output should run. So it's on N. So maybe the behavior something like this. After we are running, what is it called? After we are running the current process, it will immediately switch to the input output, to the process that initialize input output. Maybe and it is only 1, which means there's only one process either running already. Then we run the process. Yeah, I'm still not sure whether the, what is it called? Whether the get num runnable also including the input output, the process that have input output or already finished the input output. I'm assuming it does by this comment, right? So when there is only one runnable process, that means this is the only process left, so run it. Maybe, but yeah, this is something that I'm still not sure. Let's say we have two runnable process, right? One is running and the other one is this, in the ready state. If that is the case, oh, okay. But what about three process? One is running, the second is ready, and the third is this one, the PID one. What will this do? Is it the input output should be run? Oh, okay. Let me proc one. Let's do something like this instead. Okay. Like this, proc 1, proc 2, proc 3, and then this one running, and this one ready, this one ready, the one with finish input output. So, right, the runnable is more than one, something like this. So what this will do? Move to running. Change the current process to PID and move to running. Schedule switch on N. Schedule switch on N. No, not that one. Schedule switch on N. Yeah, I'm still not sure. Is it gonna be coming running after this one finish? It's done, right? It's gonna be coming running, the running state, bypassing this one. Check if done. Okay, the process exit code, if it is 0, check if the state is running. If it is, change the state to done and then going to the next process. Either this one or this one. Okay, check if done. This means the process that issued the input output should be run. Okay. Yeah, I'm still not sure about the policy in here. What is the expected behavior when we have this schedule switch on N? I'm assuming it is something like this. So after the first process is done, we immediately changing this from ready to running. Maybe. Can it depend on the policy, right? Understood. Alright, good work, man. Thank you. Okay. Instruction to execute. If current proc is running and has an instruction executed. Okay. State running and the error code more than 0, but the length. Interesting. Wait a minute. I think move to done. Not this one. Oh, check if done. Okay. It's also length. Why we use length? Yeah, I'm not sure. At first I assume this is the exit code, but maybe it is not. Okay, proc code, process code. Equals 0. Alright, why is it equals 0? I'm still not sure. Okay, instruction to execute. Okay, state running in this one. Code more than 0. Instruction to execute. Okay, this one. Oh. Wait a minute. Maybe this is the instruction. We check if there is any instruction left. I mean, if it is 0, then there is no instruction left. And then if the state is still running, we change the state to done, and then we move to the next process. Maybe that's what it means. The instruction code, the process instruction code. Maybe. I'm still making a hypothesis currently. Okay, so this means that the state is running and there is instruction left, right? Because it is more than 0. Then we are executing the instruction. First we, what is it called? We are popping the first instruction and then increase the, what is CPU bus in here? Increase the CPU usage parameter, maybe something like that. And then the output print what everyone is up to. Okay, something like this. There is asterisk, for the clock tick. Okay. Else. Oh, this is the indicator if the input output is done. The asterisk. Okay. And then instruction to execute not equal empty, right? Which means we have some instruction to execute and then run those instruction. Else just print the state, right? CPU output here. If no instruction execute, output a space, otherwise on 1. Okay. This is indicator for, what is it? Instruction to execute. Input output here. Okay. Outstanding. Okay. Still none outstanding. Okay. I think this means we are casting to string. If I remember correctly, this is a number, right? This one. So we are casting a number to string. If I understand correctly, we increase the input-output counter. Maybe that's the word. So this one, we increase the CPU counter. CPU usage counter. This one we increase the input output usage counter, or else we print space. Okay, this is just adding a new line, I assume. If this is an input-output start instruction, switch the waiting state and add an input-output completion in the future. Input-output start instruction, switch the waiting, or in this case the block state. Okay, just some kind of a reminder that the waiting state in here means the block state. Okay. Instruction to execute to I/O. Okay. Move to wait. Okay. If the state is running, I think the current process, right? If the current process is running, we move to state to wait or block. Again, wait is blocked in here. Okay, finish time, current process, append no, clock tick, put output finish time. Wait a minute. Oh, okay. We are appending the finish time. Okay. SF process switch behavior. Get your switch on IO. Again, I'm still not sure the policy here. What is the expected behavior for this process switch behavior? Okay. And case check if currently running thing is out of instruction. Okay. Return the total CPU usage, the input-output CPU usage, and the time, the expected time. I'm assuming that is the case. Like the running time maybe. Okay, parse argument. Okay, just a bunch of argument parser. Okay. Print start. Oh, random set. Okay, wait a minute. Okay. And what is the option? Oh, it is from the parse argument. Default 0. So again, default is 0. So if we did not what is it called? Did not add this flag with the argument, it becomes 0. Interesting. And what will do if it is 0? Let me try. Import random, okay. Random.set 0. Nothing happened. What about 1? What? So what random set 2? Oh, you look surprising, mate. I mean, I'm focused analyzing the source code. I mean, it's kind of interesting, to see what kind of mechanism that the source code does in Python. isn't truly random, right? It's deterministic. Detected by the seed value you pass the random state. Oh, the sequence it generates is detected by the seed value you pass to random.seed. The current time as the seed value. Oh, okay. Which means whenever you run the script, you will get a different sequence of value. Alright. Using the current time. Tonight this value is the previous number. Its first previous value. The sequence of generated value for a given random number generator. You want to set your random number generator with some value that will change its execution of the program. Okay, so it is like the initial value for the pseudo random number generator. Okay, start. Says on output. Okay, output letter. Okay, letter. Oh. Okay, what is assert in Python? Python assert. What is the use of assert? I mean, I need to know that. Is it the true? Is assert gonna throw an error when this is true or false? I mean in the C standard library, the expression is false, right? So if the expression is false, we throw an error. So if that is the case or similar in here, if the process switch behavior is not get switch on IO or get switch on N, it will throw an error. Is that it? So you can only use these two process switch behavior, and this also the same for IO-done behavior, right? Okay, let me confirm that. When the cause is clear rather than later when some operation fail. Totally raising an exception if not caught early on. It works as documentation for and can confidently say its condition holds from now on. To test that condition, okay, and immediately trigger an error if the condition is false. Okay, if the condition is false, not true. Alright, false, okay. Let's try. False, alright. So in this case, it means that if the IO done is not IO run later or IO run immediately, and this is also the same. Okay. So check for those policy, right? And then the scheduler running the class, okay. Okay, this one, not the program, okay. Equal 0, we add the option to the program, okay. Else, if it is empty, I guess, we load the program and we assert if the length is maybe less than 0, the IO length is maybe less than 0, then it will fail. I mean, if the length is 0, then yeah, it will not fail because equal and greater than. Since all false, produce this what happen when you run program, okay. Important behavior, system will switch when, okay. Process is finished or issues an input-output. The IO, the process issuing the IO will run immediately or run later, depending on the policy here, right? Then exit with 0 exit code. And then run. Wait a minute. If solve is false, we are exiting the program. Okay. Yeah, what is solve again? This one. Compute unfirst for me. Default false. Okay. Compute unfirst for me. So if the solve is what is it called? Is false, we didn't run the program. Is that it? I mean, we are exiting in here, right, with 0 code. Okay, so if the solve is true, and because the default is false, if we didn't provide this flag, the C flag, we might not run the program. Maybe I'm still guessing right now. Some print start. Okay. Let me check this first. With the following flag. Okay. The C and P flag to see if you were right. Wait a minute. Did I? Maybe I'm guessing correctly. Maybe I'm used the test C and test P flag to see if you were right. Print statistic at N only useful with test C flag. Otherwise stats are not printed. But it is false. And this default is also false. Interesting. Well, let me run with this flag first. Process list. A comma-spirited list of process to run in the form x1, y1, x2, y2, where x is the number of instructions that process should run. Okay, this is the instruction. X is the instruction. In this case, we give the 5 instruction, and y the change. Wait a minute. Let me check that one during Google Translate. Change. Oh, okay. Yeah, I'm just making sure if I understand that correctly. So like the probability, maybe that's the case. Why the change that the instruction will use the CPU or issue an input-output. So the probability whether the CPU, whether the instruction use CPU or issue an input-output. Probability. If I can type correctly, okay. I cannot type correctly. Right, something like this maybe. The probability that an instruction will use CPU or issue an input-output. If y is 100, a process will only use the CPU and issue no input-output. Okay. If y is 0, right, a process will issue only input output without the CPU usage. Alright, so in this case 100 and 100, if this information is correct, then we will only where is it? We will only use the CPU if y is 100. So we will only use the CPU for the 5 instruction. What's the CPU utilization P? The percent of time the CPU is in use. Okay. Let's try that out. CPU intro. Oh, okay. Process test run. Test L. Let's try with this one first. What does a test of what would happen? See, the default is false. So we are not actually running the program yet, I assume. What happens when you run this process? Right? If I'm doing this, thing like this, so I'm not sure if the TC is expected or not. What should the CPU utilization be? The CPU is in use. System will switch when the current process is finished. Again, yeah, what TC does. Compute answer for me. Compute answer for me. So is the .c flag in here means that we are actually running the process rather than only produce a report, something like that. And where is the pen start? Like only useful with the TC flag. Okay. So it looks like my hypothesis is kind of wrong. So the TC in here means that we will run the instruction So without the test C, we are only printing out the report, something like this. What would happen, like the report of what would happen when we actually execute the instruction, but we are not executing the instruction yet, because again the run instruction is after this condition, which is we are actually exiting after printing all of this out, exiting the program. That's why this line will not execute, and that is why the test P is only useful with the test C flag. Because again, if the solve is false, then we are only printing out this report rather than actually running the instruction, something like that. System will switch when the current process is finished or issue an. Okay, well, maybe we will explore this homework on the next session. I forgot to tell you this. Don't forget to drink enough water. Stay hydrated. And also, don't forget to eat some breakfast. Yeah, I will get breakfast after this. Okay. So I guess that's it for now. We will continue this on the next session. Thank you for watching and see you next time. Bye bye.